Right. So in this class, we are going to talk about the next unit of the fourth chapter, that is circular measure. And today we will talk about 4.3, that is area of a sector. So let's get started. 4.3, and it is area of a sector. So by now you guys know what exactly a sector is. Again, I'll make a circle. So here's a circle. This is the center. This is radius of the circle. Then here is another radius of the circle. And this angle is, let's say, theta. This is the radius. This is the radius. This was basically the arc length. And this is basically the area of the sector. So this pizza slice type of a thing is basically your sector. And obviously area is the blue shaded part of this sector. Okay, so this is what exactly area means. Okay, now again, using the same logic, the way we defined two different formulas for arc length, we can use the same logic and talk about two different formulas for area of sector. We know that area of the entire circle is pi r squared. Okay, this is the area of the entire circle. So if I want to talk about the area of sector, that is going to be theta divided by the sum of angles in a circle is basically 360 degrees, or it is 2 pi. So it's 360 degrees multiplied by pi r squared. And this is when the angle is in degrees. Okay, so it's very simple. It makes sense. For 360 degrees, it is pi r squared. For theta, it would be theta divided by 360 degrees multiplied by pi r squared. And if I talk about area of sector, when the angle is in radians, it is going to be theta divided by 2 pi, because 360 degrees in radians is basically 2 pi, multiplied by pi r squared would give you pi, and pi would be cancelled. And this is when your angle, or when your theta, is basically in radians. And upon simplification, you would get theta r squared by 2. This is basically area of the sector. Okay. So by the end of this discussion, we have two formulas here. This is the first formula, and then this is also a formula. It totally depends upon if the angle is in degrees or if it's in radians. Okay, these are the two formulas that we need to consider. Okay, all right. So yes, again, just like yesterday, let's talk about one basic example, and then we'll talk about past paper questions. Okay, the basic example is just to, get used to the formula, and then we'll talk about some past paper questions. Okay. This is example number 1, and it says, find the area of a sector of a circle with radius 9 centimeters and angle pi by 6 radians. Give your answer in terms of pi. Okay, so let's talk about the solution. It's very simple. So you have been asked to find the area of a sector of a circle with radius 9 and angle pi by 6 radians. Okay, so the question was about area of sector. Area of sector is equal to 1 by 2 r squared theta whenever your angle is in radians. Okay, I've just written the same formula in a different format. This, okay, and now I'm going to plug in the values of theta and radius. 9 square and it's pi by 6. So we are going to quickly just cancel out stuff. 9 multiplied by 9 is 81 divided by 12 pi. And we can just simplify this thing with reference to 3. This is going to be 27 and this is going to be 4. So finally, we are going to get 27 pi by 4 centimeter squared as the answer. Units are very important. Since the question was about area, you need to write down centimeter square as well, okay? So this is how exactly we are going to apply this formula, okay? But this was just a straightforward application of this formula. When we will talk about past paper questions, you guys will see that, you know, the difficulty level is varying. Like for some questions, it's direct, and for some questions, it's a bit technical, okay? All right, so let me shift to the other PDF now. First, and then, okay. All right, okay. So let's talk about the first question. It says the diagram shows a triangle ABC. Okay, we can see a triangle ABC in which angle ABC is 90 degrees. Okay, and AB is 4 centimeters. That makes sense. The sector ABD is part of a circle with center A. So they did not make the entire circle, but they have told you that the center of the circle is A. And this circle would be something of this type, right? Okay. The sector ABD is part of a circle with center A. The area of the sector is 10 centimeter square. Find the angle BAD. Now here, you have been told that the area of sector is 10 centimeter square and you need to find out this angle. So we know that, and it's in radians, okay? It's in radians. So we know that area of a sector whenever the angle is in radians is equal to 1 by 2 r squared theta, and the area of sector is 10 and the radius that is given is 4. This would be the radius obviously, and theta is to be calculated. So this would go there. 20 divided by 4 squared is 16 equals theta, and you can just simplify your answer to find the exact value. So 20 divided by 16, it would be with reference to 4. And finally, theta is going to be It's 5 by 4, so it would be 1.25 radians. Okay, this is going to be the answer. Now, one thing I would like to mention here, since we are also, doing O-levels past papers these days, so, and you guys have just done your O-levels, so you would be knowing that in O-levels, things used to be very different. There used to be a separate line for answer, and the units used to be, written here already, like meter squared, or let's say centimeters or liters. That thing was clear. But this time around, the examiner is not going to give you any separate answer space, right? Whatever you want to do, you will be doing it within these lines. So please make sure that you guys do not forget your unit. Okay, unit is very important. Okay, all right, so this is going to be 1.25 radians. That's correct. Okay, any difficulties with this?
No, miss.
Okay, and Munja, what about you?
No, miss. Thank you.
Okay, perfect. Welcome. Okay, the next part says find the perimeter of the shaded region. Okay, it's about the perimeter of the shaded region. So let's go up and see. So this region is shaded. Okay, and let's see. It is basically a 4-mark question. So this would take some time. Okay, so for the perimeter, what stuff do we have already? We don't have anything already. We'll have to figure out everything. We can find out the arc length easily using theta and radius. That can be done. Next, we have this angle. So let me just add whatever we have. We have 1.25, and the arc length is going to be, it's r theta. So it would be 4 multiplied by 1.25. And this is going to give you 5. So the arc length is 5. Let me just directly write down 5. This is 5. Okay, that's good. Next, we need to have this length. And we need to have this length, DC. Okay. So for BC, what I can do is I can see that ABC is a right angle triangle. Okay. So I can apply those trigonometric ratios that we used to discuss in O levels. So it is 4 centimeters and 1.25. So I have the perpendicular side is unknown, and this is basically the base. So I can use tan 1.25 is equal to perpendicular divided by base. 4 would be multiplied. 4 multiplied by tan 1.25 is going to give you the final thing. So 4 multiplied. Okay, make sure that your calculator is in radians mode. Why? Because this angle right here is in radians. Okay, look at this. This was given in degrees, but we were told to find BAD in radians. Okay, so please make sure that your calculators are in radians mode, and then you're doing this working. So 4 multiplied by tan 1.25, and this would give you 12.04. Okay, I am going to keep at least 4 significant figures during the working, because if I round off, in every step, I would get a very, very rounded off answer. Okay, so this perpendicular side turned out to be 12.04. Okay, so 04 centimeters and centimeters. And this is for you guys. Think about it for 2 minutes. Take 2 minutes only. It's completely fine if you're not able to find the exact answer. Just spend some time in understanding how exactly would you guys find DC.
We can use Pythagoras theorem to find the whole length of AC. Then since we already know that AD is 4 centimeters, so we subtract from there.
Okay. All right. Let's see. Very good. Okay. I'm just waiting for Rafi as well, and then we'll talk about it. Okay. But you were thinking in the right direction. Very good.
Miss, what about the perpendicular?
Yeah, sorry, this
Yes, miss.
the side DC. You need to find the side DC. Yes.
Yes, miss. We'll use Pythagoras theorem and -4.
Okay. Very good. Very good. And that would give you this entire side, right?
Yeah, AC squared.
When you will use the Pythagoras theorem, you are going to get this entire AC. But I'm talking about DC only. So
So AD is 4 centimeters since it is AB is equal to AD. So that is 4 centimeters. So
yes, very good.
we
Yes.
subtract AD.
Excellent. Okay. So this is 4. The radius is same. This is also going to be 4. Okay. And how will you find the entire length using Pythagoras theorem? So that would give you 4 squared plus 12.04 squared root. Let's do the working. So it's root 4 squared is 16 plus 12.04 squared.
$12.69.
Yes, very good. And this is going to give you 12.69. Yes, that's correct. So I'm writing this thing directly because both of you know that we have used the Pythagoras theorem. This is 12.69 centimeters, but we are interested in DC only. So we will do 12.69 minus 4. And this would give you 8.69. 8.69. Yeah, now you have this, and this, all the three sides. So in order to find the parameter of the shaded region, we will do 5 plus 8.69 plus 12.04. 12.04 plus 5 plus 8.69. This would give you 25.72. Okay. So the answer is going to be 25.7 centimeters. And this is going to be the answer for the question. Okay. Yes, Rafe. Any difficulties?
Miss, can you show me the paper
Yes,
and
yes.
the variant and everything?
Here it is.
Okay, Miss, done.
Okay, perfect. So are you sure that you're clear with the idea, both of you?
Oh yes, ma'am. Thank you.
Yes, miss.
Okay, great. This is the first question. It would take some time and you guys will feel confident about it. Okay. All right. 1 second.